Well, hello, this is week 6, and we're going to be talking about habitat fragmentation in these slides. And I'm going to be trying something different, so it might not all work out. First thing I want to talk about is how habitat fragmentation is caused by humans. And we're going to look at a few places around the world where there's a lot of habitat fragmentation. So, for example, here's Cancun, Mexico. For any of you that have been there, the resort area is out on this spit in the downtown area. And if we look at this in satellite view, we can see the effect of running a road through the jungle, the tropical forest there, and then all along where that road, the major highway goes off, little roads go off that, and then littler roads go off that. Sounds like an Ogden Nash poem, but in any case, that opening up these areas of the interior to roads ended up in habitat fragmentation. Another place that's famous for this is in Brazil. In the province of Rondônia, and if you look there, here's the big satellite image of that, and as we zoom out, you see the impact of putting in major roads. Little roads go off of that with lots of logging. This area is a flashpoint for tropical forest destruction versus personal rights versus economy. Now, on a much subtler scale than this, we can compare what goes on in the Portland area, and I'm going to compare two areas here. One is sort of Gresham, out near where we're going to be, and in the field trip. And you see, look, here's Powell Butte, where we're going to be, all sorts of connectivity out here, and you look down toward these other towns like Damascus, there's lots of green spaces, they're all connected together. And this is because of the land use planning in Oregon. And then you go just straight north from there and look in Clark County, and what you see up in the areas of Clark County is many smaller lots, like out here up in the foothills, many smaller lots. Land use is spread way out, urbanization and sort of 5 to 10 acre lots have spread way out into this area, up into Hawkinson and up in there. All this area is a lot of smaller lots, so it's very different land use, and people at Portland State are studying this, and it should be a very interesting study. Now, when we're looking at the landscape, we might look for different patterns. One is large patches or small patches. Dendritic, this would be following a stream, looks like, what's going along with the stream. Rectilinear, we just saw a lot of that in the farmland there, and same thing with checkerboard, where it's very organized, crops growing. And then this idea of interdigitated, where you might have forests on one side and encroaching human population on the other side. So this way of talking about landscape, just what's the spatial pattern on the landscape. And another way to talk about it is treat the landscape just as a network of adjoining habitat. Now, this is where we want to talk a little bit about this in relationship to our course, because we talk about networks and connectivity. And over on the left, you see 3 different examples of the landscape as a grid. And in one case, there's only 30% has been put into human use, and you have these large patches of contiguous habitat for wildlife, let's say, and then that, because 30%, there's quite a bit of large habitat that are all connected. At 41%, you start seeing it dropping off, and you still have some patches that just by chance connect. This could be a random pattern on the landscape, and there's just one example of that. And you get these large patches, and it's the largest patch that's of interest to maintaining biodiversity and habitat for populations, because that provides a way for that population to communicate, and they can be healthy, have a larger breeding population. Whereas if you look at this little patch down here of only 4 squares, it's cut off from all sides, and any population there could have a real problem. And then finally, when you jump up to 60% habitat patches destroyed, you end up with very few small, very small, and just a few contiguous areas. Again, just by chance. If you do this a lot of times, if you made random networks a lot of times, random configurations on the landscape a lot of times, and just counted what's the largest habitat, you'd see a general pattern like this where the largest habitat in below 30%, it's really pretty large and doesn't change much, but you get up in this critical zone around 41%, and all of a sudden just any slight increase in number of patches destroyed causes a large decrease in the largest habitat, the largest number of contiguous cells in that habitat. So instead of it just dropping off evenly where every new insult to the environment is equal, we have this sort of threshold, a critical level, and a threshold. Above that, you get this large drop-off. So if you could just keep the habitat fragmentation in some of these areas below 40% or something, you maintain a lot of very large habitats, which would be good for biodiversity. Now, one of the things that I want to talk about is why why we are trying to deal with these corridors and habitats. Now, humans cause habitat destruction, but there's consequences to both the animals and humans from this. So when we fragment a habitat by putting in a road or a shopping center or something like that, the wildlife often still has to get through that space. And one of the places where this comes into very stark results is on the highways. We have a large number of animals that get hit on the highway, especially in the western states out here. As deer and elk and other things try to cross the highway, they come into contact with cars, and this causes a large amount of damage. This study I'm referring to here was presented at Boise State and shows a lot of these types of damage. And up in Canada, you get like moose damage. It's even many people are killed. Lots of cars are damaged. There's a huge impact, of course, on the population of these large animals. And one way to deal with this is to actually explicitly address the habitat fragmentation and try to put in ways to allow species to get from one part of their habitat to the other. So here's an example, a very sort of extreme engineering example where there's a whole park that goes over the freeway, and this whole park allows animals to go across. It's not narrow enough that predators can just sit there and pick off animals as they come across. And this is one possible remedy. Another remedy is to put in underpasses, and this has been used in the Oregon area quite a bit. Here's a picture you put in some cameras and follow what's happening so you can see how well these underpasses are being used. Here's an elk in the underpass, and here's another example of a bobcat going under a bridge. So this is another example of a type of very short corridor that would connect some regions that were high biodiversity on both sides. Now, I'm going to stop part 1 there and pick up part 2 in a little bit.